Good afternoon, everyone. Thank you very much for taking time out of your day to join our webinar. The webinar is an introduction to safety critical task analysis, SCTA. My name is Mike Sherman. I'm one of the principal human factors consultants here at IHF. I've been in human factors around 12 years now. I've had a mixture of consultancy and regulatory type roles, working across primarily defense, oil and gas, as well as some nuclear work. And now I'll pass you over to Chizram.
Yeah, welcome everyone. Good to see you here today. I'm Dr. Chizram Rankwo. I'm one of the senior human factors consultants at IHF. Almost 10 years of human factor experience now across academia, healthcare, oil and gas. So I'm currently at Consultancy now with IHF at the moment. Very happy to be here with you today to give you sort of an overview of safety critical task analysis. So myself and Mike would be going through just a brief overview and an introduction of what safety critical task analysis is all about. Yeah. Okay, so yeah, what we'll just be going through today is just going through a brief definition of what safety critical task analysis is and how we carry that out within IHF, which is integrated human factors for those who might be wondering, and also regulatory requirements that guide this methodology of safety critical task analysis, and what our solution is as IHF regarding SCTA and the benefits it provides for our clients and multiple organizations that do use them as well, and there'll be some references for it for the reading. And at the end of it, we would have a session where you could ask us questions. So if you have any questions as we're speaking, please make well to use the chat functionality or on your end to pop in your questions, and we'll address as many of them as we can within the time that we've got available. So yeah, let's get started with what we have for today. So I know a lot of you, some of you who have joined would obviously have heard about the term safety critical task analysis, right? And this is a methodology we use within human factors, the human factors discipline. Some might be wondering, what's human factors about? This is pretty much a methodology which we adopt, or a discipline that looks at how humans or how people interact with their tasks, with their work environment, with the equipment they use, in order to make sure it's easier for them to do the right things or make the right decisions, and make it more difficult for them to make errors, while they're doing that. Now, what safety critical task analysis does is that it helps us focus on those tasks within whatever we're doing, within our processes, that could lead to major accident hazards, major accident risks, and how these tasks are performed, so that we could elicit possible areas where human errors could happen, or where human failures, violations could also happen as well, or where people could make mistakes. And that's what essentially safety critical task analysis is about. Now, we all know that human error is human nature. I don't think there's anyone who's here that has never made an error before. I'd like to meet you and shake your hand. Well, I think human error is human nature. We all make mistakes. I mean, you could go into a room, you forget what you even came there for. Right, so human failure is part of our daily activities, and that could happen in multiple ways. We could have it in form of what we call slips. So slips are usually when you do something you didn't intend to do, right? And that's what we call a slip. And we also have what we call lapses. Lapses is you forgetting to do what you were meant to do. Okay, and then we have mistakes, which is you do something you intended to do it, but that thing was the wrong action for you to take at that point. And of course, we've got violations, which are what they are. When you do something against what the written down procedures are. A lot of the time when these happen in normal day life, it doesn't lead to anything. Some of us here, I do it all the time. I plug in my phone, I forget that I haven't switched on I hadn't plugged in the charger, and I wake up in the morning and the battery is 10%. No much consequence to that. But if you take that same scenario into a very major accident as an environment, then you can expect what could happen. It could lead to a very catastrophic event, and that's why safety critical task analysis is very important, because it's not in the context of things minor. It's looking at things in a very major accident hazard scenario. But the good thing about this is it doesn't just stop here, right? It doesn't just stop at the human failure. It goes further to probe why these human failures happen. And that's where we have what we call performance influencing factors. Now, what these performance influencing factors do is that they exacerbate or they increase the chances for a human failure to happen. And these could be factors that stem from, the way our jobs being designed, the environment we work in, the people doing the task, how trained are they, how competent are they, the organization factors like, the safety culture within the organization, how, the roles and responsibilities are shared within the organization, and what the safety culture is like generally within the organization. But once we have these performance influencing factors, predominant in human failure, what you then have is that you go on ahead to create an unsafe factor condition, okay? And once you create that unsafe factor condition, the next thing that happens is you're more likely to have an incident because you've done something wrongly, or you've created a condition where errors could happen or violations could happen. And the unfortunate thing is once these incidents happen, if we do not have preventive measures or mitigative measures to fail to, and we fail to recover on time from those errors that we've made, we end up having catastrophic events. And worse still, if we don't have measures to recover quickly, they just keep cascading and escalating until it gets to the point where everything goes bust, right? So the role of safety critical task analysis is to look into the critical steps within our procedures or within the way equipments are designed, etc., to pick out those critical steps where these errors could go wrong, where these human failures could happen, and make sure that we've addressed them in our controls, through whichever way we control them, safety-wise, etc. So that's the major thing that, safety critical task analysis does. I'd like to also point out here that, while we're saying safety critical task analysis, in major accident hazard context, it's not solely for, safety, right? It's not just in the safety space that we implement this. In fact, quality teams implement this as well. I remember working in a high hazard lab, in the UK, hazard group 4 lab, where, you deal with things like Ebola, etc. And as part of the human factors and safety critical task analysis we did discover that one of the key areas where errors can happen, for example, is when you're manually dispensing samples, right? So what did we do? We had to come up with a design of having automated dispensers to reduce that reliance on the humans making an error in dispensing, because you could then send, instead of sending 1,000 ml, for example, of a sample to a laboratory, you're sending maybe 900, and that affects the quality of it. So it's not just the safety aspects, but even the quality of what you want to do, okay? Sometimes it could be just the fact that you're manually scanning, you're manually packing things, and then you could make an error. Again, because of performance influencing factors, you're constantly thinking it's a long day at work, etc. And then you make a mistake. But what could take that are probably bringing in automation into the process using things like barcode scanners, etc. So I just thought to point that out, that despite where, this session is on safety critical task analysis, but this same methodology could be applied for, quality, your business critical consequences, productivity, and things like that, performance as well. Okay, so it's not just the safety aspect of things. Okay, yeah, so we could move on. And the main thing we're trying to ensure when we carry out safety critical task analysis is that the way your procedures have been designed, the way your processes have been designed, we want to make sure that there's that alignment between how you imagine these processes to go in an ideal situation versus how it's actually performed in reality. Okay, so that's what we call the work as imagined versus the work as done. So your work as imagined is usually captured in how your procedures are written out, how they're designed, the safe systems of work you've got, etc., etc. But the work as done is how the work is carried out in the field. A lot of the time, what we find is, especially with experienced operators, and this is really important because we do think that, for those who are very experienced, they would never have an accident. If someone should come and ask you, what's your control to make sure accidents don't happen, you say, we've got trained operators. That's great, but that's only just one level of control, right? Because even like I said earlier in the previous slide, you've got the chance to have sleeps or lapses, and sleeps or lapses are very common amongst those who are competent, because you could have people who are well trained, but they're tired, they're fatigued, there's distractions in the workplace, the equipment is not well designed. All those things could enhance the possibility of them having an error. So we want to ensure that the way we design our procedures is so that in such a way that we cut out any of those errors that could happen in our, through the way the procedure has been designed, and make sure that it's foolproof, okay, and make sure it's absolutely aligned. So we do this as part of the safety critical task analysis procedure, and we found that this is what creates the most success in that process as well, okay, to bridge that gap. And again, this is sort of the roadmap from the regulatory perspective by the HSC. Again, this is what was designed for major accident hazard industry sectors like, you know, your oil and gas, nuclear, etc. But again, this same principle could be applied in non-major accident hazard contexts. Okay, so we, for example, with the healthcare example I gave, it's not necessarily a health and safety executive regulation because they're not a COMAH site, right? And COMAH means, for those who don't know, a control of major accident hazards. So they're not a COMAH site, but the methodology could help you meet the regulations within your sector because, you know, of how it's been implemented. So the idea is that, you know, from the major accident hazard scenarios, you know, things that could lead, you know, you have different scenarios, things like explosions or fires or structural collapses, etc. You identify those tasks from a safety and environmental perspective that could lead to those major accident hazard scenarios happening, and then you do what we call a task analysis, which is pretty much breaking them down into very granular steps, as granular as possible, so we don't miss any important detail. And then we do an analysis of the human error, things that could lead to slip, slaps, mistakes, violations, and we evaluate, firstly and more importantly, how do we engineer out controls that can automatically take the human out of the process as much as possible. Okay, that's the first thing we want to be looking at. Then there are certain things we can't always engineer. Those are the things we then look to optimize the human side of things to see, okay, for the operators doing this, how do we ensure that they're well trained, they have the right information, they know what they're doing, and, you know, it makes it almost foolproof for them. Okay, so that's where we go down the other side of implementing it. But this is sort of the roadmap we take when we carry out this process of safety critical task analysis. Okay. Yep. Right. So within IHF, one of the key things that we've put together is a process that's self-aligned to what the HSC wants. And the first way we do that is what we call task screening. So task screening is a way we go about identifying all the tasks within your organization that has a safety critical element to them. Okay, so we gather all the inputs that could be from your procedures, from your hazard reports, from every single thing, risk assessments. You know, we get every single detail about all the tasks that you do. Now, when we screen these, we create what we call a task register from these. And that task register is done by screening these tasks for their criticality. And we do this using a methodology, you know, created by the HSC as well and tailored to your industry sector. And once we screen those, we only focus, and this is important, we don't do this for every single task, okay? This safety critical task analysis is only focused on those tasks that have a propensity to lead to a major accident hazard. So we won't expect you to do this for every single task within your organization. Trust me, something that does take time, and we won't want to play down the effectiveness or the efficacy of this process. So only focused on those safety critical elements of your organization. And what we do is we score these tasks based on a risk prioritization scale, and we go ahead to prioritize them. And from those prioritized tasks, we pick them one after the other. We build what we call a hierarchical task analysis, or sometimes a tabular task analysis. Again, we just focuses on breaking them down into granular detail. Once we've done that, that shows the step-by-step, you know, procedure of how we carry out those tasks. And from that, we use that document to carry out a site-based walkthrough. So that site-based walkthrough goes through a systematic, you know, from boots on to boots off. We're saying, okay, how is this procedure performed on your site? Walk us through that procedure. You take us through that procedure step by step, and we're capturing findings. This is probably where this might be a gap here. This might be a gap here. This might be physically on site, and we capture that discrepancy again, thinking back, comparing work as imagined versus work as done, right? And when we do that, that's when we then come to the next step of carrying out a human error analysis. This is where we start looking at, okay, what are the things that could lead to slips, lapses, mistakes, violations? Could it be information retrieval errors, or could it be the way, you know, action errors or checking errors or violations, things like that, okay? And we do that. Once we do that, we look out for the gaps, performance influencing factors. We come up with a comprehensive report at the end, and then we analyze those and send that in a comprehensive report. And those are integrated back into your safety management system. Important thing to note as well is that, again, the whole idea of this is that we're not expecting you to go back and retrain your staff as the only control. That's just one element of it. The thing is, we want to make sure that you're tailoring whatever you do as you're finding from this to the appropriate control measure. Okay, so making sure you're reducing the things you've picked out to as low as reasonably practicable as stipulated by the HSC, and making sure you map the right errors to the right controls. Okay, for example, if someone is very experienced that makes an error, I don't think retraining that person would do any good, because they know the process. They've just made an error. So, but sometimes what we find and what's frustrating for the frontline workers is they make an error, we go back, we train them. They're already trained. We should think more about optimizing the system to prevent those errors from happening. Okay, things that would make it more difficult, like error, prompts and safeguards within the system that would prevent those from happening. So at this point, we're going to navigate to the regulatory aspects of things and more detail as to what IHF provides with regards to this. So I'll hand over to Mike at this point.
Thanks, Hisham. So before I start on my slides, I just want to share a bit of a story with you on SCTA. So when I joined the HSC, I was Human Factors Specialist Inspector in my previous role. I went out to an organization who was new to SCTA and had just started a program of work to get their way through the tasks. And we went and sampled one of these, and the task we were looking at was for a slam shut valve. So this is a giant bit of kit that was designed to operate should there be high pressure. And every 6 months, they needed to go and test this valve to make sure that it would operate as they expected. And there are effectively sort of 2 elements to that test. There was a mechanical part and electrical test that they were conducting. And it started with the mechanical test. So they would isolate the valve. They would add pressure past the threshold that they're expecting the valve to shut. And then the operator in the field and the control room could confirm that that valve had operated. Once that was done, they sort of left the compound where this massive valve was located and went to an electric control panel that was sort of in the same area, kind of close. And they run a number of tests there as well. So they were checking that it would operate from this panel as well. Again, the control room could see that that was happening. And part of safety critical task analysis and being good at it is knowing when to ask questions, what, why, how, even if you think it could be, a silly question potentially. So I asked, okay, during this process, we're in the electrical test part now, but previously we've isolated this valve, including this very small sensing line that went into the valve that would tell it when to shut at high pressure. I said, these tests we're doing, the electrical ones, would this flag any issue if we were doing this without that line connected? And the answer was no. And I asked, oh, okay, how about the control room? Can they see that that sensing line has not been reconnected? And the answer was no. And you could sort of see this whole group of people looking at this valve going, we are now fully reliant on a single operator in the field remembering to reconnect that very small sensing line back up to this valve. Otherwise, it's not going to operate under any pressure. And effectively all these tests we've done have just created a more unsafe space. So that was really good to see kind of this whole group go, oh yeah, that is the case and we need to do something about it. They went away and looked at what controls they could add. So, could they remove the requirement to test the valve? Could they change the valve so it didn't need to be perhaps tested as frequently? And they kind of worked their way down the hierarchy of control and got to the point where they still needed to do this test. They needed to keep the valve, but they needed to optimize that person doing that task and remembering to reconnect it. So they added a few things. They added a signature point to that part in the procedure. So the operator had to sign off to say he'd reconnected that. So that's a positive. They added a prompt in the control room, which was a reminder window that came up to radio that field operator and tell them to reconnect the sensing line, make sure it was connected. And the final thing they did was add a clip to that part of the sensing line which you needed to disconnect. And that could be clipped on to the operator. And in fact, it was quite a small piece of line that you took out and would be quite fiddly and easy to lose anyway. So it was kind of a benefit to the field operator to be able to clip that onto himself and it acted as a reminder. If he got back in the van and he still had this bit of line connected to him, he knew he needed to go back and fit it. So yeah, it was just a really good example. It brought it to life to me about how important it is and how we are placing a reliance potentially on a single person remembering to do a single line in a procedure correctly, and that's not a good position to be in. So coming to the regulatory requirements, there is a pretty strong regulatory requirement in both COMAH and in the offshore regs for conducting safety critical task analysis. I'll go into a little bit more detail about COMAH in a minute, but yeah, COMAH and offshore installations are pretty familiar with safety critical task analysis, and if they're not, they certainly should be, because it's well defined in their regulation. For these other industries I've listed, safety critical task analysis might not necessarily be in part of their regulation, but it is seen as good practice, and it can bring benefit to those sectors. So it is something that should be considered. So for COMAH sites, we have the Human Factors Delivery Guide, and topic 1 of that is managing human performance. It's topic 1 of the delivery guide for a reason, because it's very difficult to do the rest of the human factors topics correctly if you don't know and haven't started to manage your safety critical tasks. So human factors specialist inspectors who come to COMAH sites will often start on topic 1, and they'll start to look at whether that site has done SCTA and how well they've undertaken it. So what can IHF do to help organizations with a program of SCTA? So we are a registered consultancy with the Chartered Institute of Ergonomics and Human Factors, CIHF. We can do a number of things. We offer an accredited training course, which I'll talk about in a minute. We can provide consultancy services, so we can assist you in a full program of SCTA, or we can help you with various stages of that program of work. And we have also developed our own software, which supports you through the process of safety critical task analysis, ensures that you complete each step, and generates a report for you. But I'll talk a little bit more about that in a minute. So in terms of our consultancy services, like I mentioned, we can set up and run all elements of an SCTA program. So we can work with organizations to put this in place, a procedure to carry it out properly, and then we can undertake the process with you alongside your staff and personnel. I would advise you to seek assistance if you are thinking of setting up an SCTA program from a consultancy like IHF, as there are a number of pitfalls when undertaking SCTA, many of which I've seen both through consultancy work and through my regulatory previous role. Some of the pitfalls you can fall into are missing tasks. So people often think about the operational tasks that they do on that site, but forget that there are maintenance and non-routine and emergency tasks that are also safety critical and should be considered. It's important that they're all in your task list. Another very common pitfall is confusing tasks with procedures. They're not necessarily one for one. A procedure could be written for a whole system, so all the tasks associated with a particular valve or a particular piece of kit. Within that procedure, there's likely to be multiple tasks, and it's important that safety critical task analysis is performed on a discrete task with a start and an end point and a change of status in between. It's not necessary that a procedure would be one-for-one task to procedure. Another big problem with SCTA that you could potentially fall into is that you generate a lot of paperwork doing SCTA. So notes of walkthroughs, you have evidence of who attended certain workshops, notes on your error analysis discussion, for example. All of this evidence is required and needs to be captured somewhere. And it's very easy to lose part of that. So that's something to be aware of, and I've seen that happen before. Something else that is possible is that you capture your performance influencing factors for either the whole task or for separate steps, but not both of them. This is something I've seen done before. We need to capture performance influencing factors for specific task steps, but also for the task as a whole. And finally, an organization could fail to implement or audit actions. In my experience, that's because they either don't understand the actions they've been given, or because they don't have a suitable background process to ensure those actions are managed and actually implemented. So with the reports we produce, all our actions have context, so there's an understanding as to why they've been created and what error they're trying to prevent. And then we also have a system in our software in which you can audit and confirm that those actions have been implemented. So we offer a 2-day training course. This is the fully accredited CIE Haitch-F course that we run. It's very hands-on, very practical. Takes you through the full range of SCTA from start to finish. You have the opportunity to conduct safety critical task analysis on a task that you know, that you're aware of, and we run through that with you. We pick up on any mistakes, any questions, and by the end of it, you should have a very good understanding of safety critical task analysis. This is a really good course for anyone who's going to be moderately to heavily involved in SCTA. We then also do provide a 1-day SCTA awareness course. This is a much lighter touch and is really useful for people who might be involved in perhaps a couple of workshops through the SCTA process. And it gives them that understanding and that realization as to why we are doing what we're doing. As I mentioned, SCTA generates a lot of paperwork, a lot of notes, a lot of documents, potentially a lot of pictures, perhaps some videos. All of this needs to be captured and recorded in one place, so you have this one view of the truth. Losing that information partway through the SCTA process can be really problematic, can result in you having to go back multiple stages or potentially even starting again. If you are being regulated for SCTA, inspectors will expect a full range of evidence to have been collected to support your SCTA report. You can't just have that nice, pretty end result. These are our actions. You need the story to tell as to how you got there. At IHF, we've developed some really smart software that can help you with safety critical task analysis. This software can take you through the full process from start to finish. So from identifying your tasks right at the beginning, screening those tasks, through to conducting your task analysis, running your error analysis workshops, and then an automatic report that's generated at the end. It gives you that full, complete record of what we did and how we got to the final point and how we've got these actions at the end. All the documents, all the notes, all the evidence that you capture throughout this process can be all captured in one place, and you've got one single version of the truth. You can go back to it at any point. You can regenerate reports if they're printed and lost. It keeps it all in one place. We have a great number of organizations that use this software, and all our consultants use this as well, so we use it in-house. The software has been around for a fair few years. We've made upgrades throughout this time. The software developer is an in-house IHF staff member, so we have that ability to make changes, and it's a great piece of software to use. So just briefly, the kind of solution benefits that IHF can bring. So ultimately, you know, the original intent and the primary role of SCTA is to protect humans and the environment from harm. That is where it originated. As Chizram mentioned, we can also use it for performance and quality gains as well. But the original intent, protect humans and the environment from harm. Through that, we will address HSE and the EA concerns that they may have. We can help organizations increase their operational efficiency, potentially reducing costs. And we can also enhance quality assessments, as Chizram mentioned. Our TASC software can save weeks of time, both if you lost some of the evidence or some of the notes you had made. It can protect you from that kind of incident. It can also automatically generate a report for you. That also saves a significant amount of time. TASC software maintains one single version of the truth, and that's very useful if you are regulated, or if you need to go back, or if you want to share the SCTA process with somebody else. You have one place to go to where everything is captured. There are a number of references that we've probably mentioned today. I would recommend you take a look at all of these as they're as and where they're relevant to your sector that you work in. The one I would really recommend you take a look at is the second one down, the Energy Institute guidance. That really is considered the gold standards for conducting SCTA. And it's a very well written piece of guidance. So I recommend you take a look at that if you are interested in SCTA further. That's everything that we had planned apart from the Q&A. So I'd like to thank you very much for joining the webinar. I hope you've enjoyed it. And if you do have any questions, we're now happy to take them, and hopefully we can provide some answers.
Yep, thanks a lot, Mike. If there's anyone who has questions, if you could do well to put them in the chat. I can see a few coming in already. I'll just ask some of those, but if you could pop any of the questions you've got in the chat, or even if you probably come up with questions much later, you could get in touch with us at any point in time, and we'd be more than happy to address any of those. Okay. Right, so I've got a question here that says, how do you think about screening for safety critical tasks? Do you have a criteria for what you include or exclude? So Mike, I think I'll hand that over to you.
Yes, so usually the way that we work with an organization is that we'll ask them to gather a list of procedures, risk assessments, and information from individuals working on the site. So try and get a full list of the tasks that they perform. And then what we do is we run through the screening process. So the screening process is a set of 5 questions taken from good practice. We can tailor those questions for the sector, so we can slightly change the prompt and the wording such that they are relevant to that sector, and that's something that's recognized in good practice. And we run through those 5 questions, and there is a threshold at which those tasks move into what we call high critical. So if they receive a score of 9 or above, they move into this high critical category, and then they are taken through the full process automatically for safety critical task analysis. Those that are scored as a medium, it's advisory to look at those, and we usually look at those as a case-by-case basis. Those which score a lower score, there are other human factors techniques which are more applicable to those types of tasks.
Thanks for that, Mike. And yeah, I think it's one of the key things as well is, so like I said earlier, we don't, the whole idea is not to run this on every single task, okay, that you do. It's only for those that have potential major accident hazard consequences to them. So the expectation is, if, as you saw from the health and safety executive flow chart, is that you've already identified what your major accident hazard scenarios would be. So those activities that you do as an organization that could lead to, you know, major accidents as well. But again, we could help you out with that also. Okay, yeah, thanks for that. We've got another question here. It says, how many SCTA assessments are typically completed in a year?
Yeah, so we need to acknowledge that SCTA is a fairly resource intensive activity to undertake. You know, that is recognized as a sort of drawback of SCTA. Despite all the advantages it brings, there's no way around the fact that you need to work with operators, maintainers, etc., that, you know, organizations may have to take off the line or take away from their core job. So that needs to be balanced when you think about how many you're going to do a year. Typically, I think the advice would be between 4 and 6 is good, but that needs to be considered in the context of how many tasks in total that site, you know, needs to assess, and the size and complexity of the site. But 4 to 6 is probably a good starting point in terms of how many you should be thinking of.
Yep, that's really insightful. Thanks, Mike. I think this leads on nicely to the next question. You know, so if this process of SCTA can only be used for tasks that are already in operation, or can you use it for tasks that are used, you know, during still in the design stages as well?
Yeah. So if you look at good practice guidance, they're more typically are referring to tasks that would appear to already be in use, you know, like they're actually on a site being used. But they also discuss that you can use this through the design phase, and we've used it successfully through the design phase. So you can look at, if you've got a new piece of kit or a new modification to a site, or potentially a whole new site, you can look at, okay, what are tasks that are similar, what operations are similar, what other piece of equipment is similar, what experience do we have in terms of personnel, operators, maintainers who might be familiar with a type of kit that's similar, and we can look at, you know, the design model or design drawings, and we can run SCTA with that type of information, and there can be a huge benefit to doing so. You're at an early enough stage potentially where you can design out some of those errors. You know, it's far less costly to design them out at that stage. What's then necessary is, once that facility is up and running, or that piece of kit is installed, whatever it might be, you then do need to go back to sort of the walkthrough part of the process and just verify that those assumptions that you made were accurate, and perhaps update the assessment as required. But yeah, certainly it's a good thing to do if you have the opportunity. It's potentially a really good design process.
Yeah, no, absolutely spot on. It took me back to one of the projects I was involved in with SCTA. We actually carried it out on a facility that was still being built, but the procedures were already being designed for when it would be built. But at the same time, you know, it was a good opportunity to capture any sort of, you know, design feedback that would be necessary to give back to the designers of that facility to include or exclude from the design of that facility when it was being built. And the point you made about, you know, doing a follow-up walkthrough once it's now in operation is absolutely valid as well. So thanks for that, Mike. Thank you. Okay, I think another question here. So I think this one says, what if some of our tasks are very similar or same, but on different pieces of equipment? Can we still do SCTA on those as well?
Yes. So what you would look at in that instance is how to group those sets of tasks. So you can, if you have a lot of very similar tasks, you could look for, okay, what's the worst case or most complex version of that particular task, make that the representative task, carry out your SCTA assessment on that task, and then for those other instances, you would just look for any differences. So you could just check that there's nothing significantly different that is likely to have a safety consequence that you could look at separately. So yeah, that's a very good question, and one that comes up a lot, because potentially some large complex sites can run into the hundreds of tasks, even hundreds of high critical tasks that they will need to assess, and without doing that sort of grouping activity, you're going to be there an awful long time. So yeah, that's a good question.
Yep, thanks, Mike. And I think these are the questions we've got at the moment. If any other questions are there, you could still send them through, or like I said, get in touch with us and we'll be more than happy to answer those as well. So yeah, I think I'll hand it back over to you, Mike.
Okay, brilliant. Well, like I said, thank you so much for joining this afternoon. Really appreciate your time. Just before we go, I would recommend that you have a look at our website. We have a new tool on there, which can give you a human factors maturity assessment. So you complete a few questions on there, and it will give you a fully tailored report outlining your areas of strength, areas of potential opportunity for human factors, and it will give you recommendations for how to make those improvements and sort of close those gaps. So I would recommend you take a look at that on ihf.co.uk.
Yeah, and Mike, how much would they have to pay for that?
That is completely free. Yeah, free customized reports. So a good opportunity to grab that.
Yep. Okay, so I think that will be everything, but thank you all so much for joining today. And like I said, if you have any further questions, just either give us a ring or drop us an email. I will be more than happy to respond to any of your questions, or offer help or support wherever needed as well. So thank you all so much for joining, and see you soon.